Hi, everybody. First things first, I moved the assignment. And so it was supposed to be this Thursday. It's now on Sunday. The reason for that is I wanted to make sure we cover enough stuff this week so that you have, and then have time to study for that. So it'll be next Sunday or this coming Sunday instead of this coming Thursday. Same content, still functions, everything else, but I just moved the time. Thank you. Go ahead and mute me there, buddy. Hopefully that's not a problem. Okay, what was I talking about? I moved the assignment. That should be good for you, not bad. The next assignment after that will probably be on the next Thursday, but I always keep track of these things in D2L. So you can see right here on the side, tells you when the things are. Just keep an eye, shouldn't be a problem. Obviously, all this stuff here is old news. Other things, in content now, you've got quite a lot of information, but hopefully it's not too overwhelming because it's bit by bit. Of course, course information, I added my schedule. You can scan that. It's just a QR code. Just scan it. It'll bring up my full schedule so you can see where I am all the time. Well, I'm always at home, for one thing, but you can see if I'm working, if it's my office hours, if I'm in class, and so on. So you don't annoy me too much while I'm in the middle of something important. YouTube playlists, nothing new there. The assignments, this is where you'll find all your assignments at all times. So, if you're lost, you don't know where the assignment is, it started 3 minutes ago and you need to get to it right away, this is where it's going to be. Speaking of the assignment, I put the answer key online. And so for those of you that got your feedback, which you should see all my check marks on it, the percentages, make sure that you don't have a blank PDF in your Dropbox. I sent you all back a marked assignment. This is the key, so you can see exactly where you might have lost marks. Some of you, I had to be very creative in how I gave marks for the third one because there were so many little mistakes. And so I hope that you'll find I marked you as fairly as I humanly could. In fact, I think I marked very fairly because, like I said yesterday, I should have given some zeros, but I didn't. So that'll be a lesson for next time. Under assessments and grades, you'll see your grades. So for example, I didn't do the assignment as me, and so I obviously don't have a mark there, but you could see it, and you can even see the class averages if you're interested, and you can see that everyone did very good. Almost everyone got above 75, and no one failed. So it was excellent, I think. Finally, the overall feedback here is not feedback for you. It's, oops, I don't know what I did just then. It's not feedback for you, it's feedback for everybody at the same time. So you can look at that and see where the main problems were for everybody. All right, I think that's about it. I don't think I have anything else. Oh yeah, my handwritten solutions. I probably didn't need to record all this, but whatever. Under course notes, you'll see Unit 1 notes, Unit 1 answers, Unit 1 handwritten notes, Unit 1 solutions. It's all there, and you'll see that in Unit 2 it has the notes as well. I meant to post the Unit 2 notes in there. They are there, of course, but they're under functions. So maybe I'll copy it over to the other place as well. Sorry if that confused any of you. Okay, so before we get into the actual content, which is, of course, the book stuff, we're going to start graphs, domain and range, and piecewise functions today. Are there any questions about anything whatsoever?
Yes, Mr. Scott, I came to the previous class, so can I love this one? I was with you in section 3.
Yeah, it's okay. It's going to be the same. I'd appreciate it if you didn't normally do that, if you can help it, just because I kind of get in trouble with my boss if I let students do that. But I'm also not going to tell anyone if it's just a few students every now and then, okay? So if for certain days you cannot make the other section, yes, of course, come into the other section. It's all the same. The bigger the better as far as I'm concerned, but just don't tell anybody. Don't tell anybody important so that I don't get in trouble. Any other questions? About the assignment, about the course? that a no? Going once, going twice. Sold. All right, let's start. We have 3 things to cover today. In my opinion, it's actually there. What was the question? Don't worry about it, man. 3 things to cover today. Graphs, which you've already touched on yesterday. Domain and range, which means what are the possible x values and what are the possible y values of the graph. And then piecewise functions, which are 2 functions stuck together, and they have specific domains, which we'll see very soon. Okay, so let's get back to where we left off last time, which was reading values from a graph. So this is the last thing we did yesterday. I'll just quickly recap it. You should know what it's called when a function is in this form. And it's called function notation. And it tells you what x values are being put into the function. So in this case, we can see that it's asking us to find what the function's value is when x is 2. That's actually very easy. You know, if this is our x value, just go looking for 2. You can say, okay, well, it's at that point on the function. What is the associated y value? It must be 3. So the answer, the function's value when x is 2 is 3. That's the final answer. That's it. It's basically also the coordinates or the ordered pair for this point here. You could say 2, 3. Same idea. Okay, so the final answer is 3. We did that last time. So what I'd like you to do, just as a quick review, and I didn't do this, Tom did number 1. You know, Tom did this one in the beginning. I'd like you to try B and C. Just tell me what the answer is. It's just a single digit answer. You can write in the chat. I just want to make sure everyone's alive, keyboard's working, brains are working, and so on. What is the value for this one when x equals 2? What is the value of this function when x equals 4? B is 1. B. B. What's B? It might be B. Oh, A and B. Interesting. I understand. Okay. When x is 0, let's see. You're getting a 1. I agree with you. So that's a 1. Perfect. 100%. Good job, Ibrahim. Thank you. Anyone else? Oh, B. Question B. Remember when I told you that this is the worst time of day for me? That's the kind of thing I'm talking about. All right. F equals 4. Well, okay, F equals 4. 4 is over here. What's the value when F is 4? It looks like it's also 4. Okay. I'll take it. No big deal. And if you want to be crystal clear, you can say that this is the function, sorry, this is the ordered pair 0, 1 over here. And this is the ordered pair 4, 1. Now you might remember yesterday, C is 1 also. Yeah, exactly. You might remember yesterday we talked about what is a function and what is not a function. So in this case, it passes the vertical line test. We can put a vertical line anywhere we want, and it only crosses once. So it's definitely a function. But in this case, we have, wait, I got 4, sorry. 1, sorry about that. In this case, we're getting 1 twice. Is that a bad thing? Shouldn't we never get the same number twice? Well, in this case, no, because remember, it's the input needs to have a unique output. We're allowed to have the same output twice. So look, if I put in the x value 0, I get a 1. If I put in the x value 4, I get a 1. That's okay. That's fine. We're just not allowed to go backwards from that. You know, we're not allowed to have a 2 give us a 3 and also give us a 4. That would be a bad thing. But the first 2 are perfectly fine, okay? That's just a little aside. You don't need to keep that there. So reading functions, reading ordered pairs from a function is very simple. I hope you'll agree with that. What we're going to do next, or at least in a couple pages, is we're going to be doing something a little more complicated that uses the same idea. Okay, so let's move on and see what's next. Graphs. Ooh, fancy. Well, we've actually already done graphs, so that's not so exciting. What I'm saying you need to do for the graphs section, so this is for most graphs, you need to know how to extract the ordered pairs, which means look at the function and get some important, I'll say, important points. So for example, where does it cross the x-axis? Where does it cross the y-axis? Where's the bottom of a curve? Where's the top of a curve? Things like that. And then you'll need to do a rough sketch of the shape, which Desmos will help you with. So let me move on. Example 8 was already done by Tom. So I'm going to move on. This was already done by Tom. This was already done by Tom. This was already done by Tom. And now we get to the practice. What we need to do is sketch these functions. We need to sketch linear functions, we need to sketch quadratic functions, and we need to sketch cubic functions. So let me put a little dream sequence over here to the side to help you understand what one's which, okay? If you have X form, for example, you see an X and nothing else. This is linear. In fact, I'll make it a little better. If you have a constant in front of the X, but it's just an X, the highest power is 1, it's called a linear. If you have a positive number in front of X, it looks like this. That way, climbing uphill from left to right. If you have a negative value in front of A, we're going to look like this. Okay, so just let me make this as clear as I can. I don't want them confusing you. This is a negative number in front of the A. So I can give you an example. For example, maybe this is 5x. And for example, maybe this is negative 3x, plus or minus something, whatever. Okay, that's what lines look like. I'll give you a chance to interact with me in a second. I just want to get all this out of the way. What's the next type? Well, ax squared form. Any of you who have done physics, probably even other math courses, you might know what this is called when you have a squared form. It's called quadratics. So you have quadratic form, which means a curve. If you have a positive a, or you have a positive number in front of it, let me see this. If you have a positive number in front of that, it's not going to look like a line. It's going to look like this. It opens upwards. If you have a negative, it opens downwards. So the silly way that I remember this, and it is silly, but I use it all the time because I still think about it. If it's a positive number in front of x, that's a good thing we can think of it. Positive means happy. So it looks like a happy face. It's a one big smile. It's curved upwards. It's a good thing, positive, smiley, all that thing. If it's a negative, negative is like kind of a sad thing, right? So we say that it's a bit of a sad face here. I don't know, I kind of half sounded like Donald Trump there. Sorry about that. Terrible. Anyway, negatives bring negative curves downward like this. Positives, upward. So for example, maybe this could be a 3x squared. And maybe this one could be a negative 4x squared or something like that. The important thing is that it has a square next to that x. Okay. You can probably imagine where I'm going to go next. If you're listening, maybe you've already signed off. I hope not. This is not too boring, I hope. A x cubed form. That is called a cubic. It shouldn't be a surprise. It's a cubed number. It's called a cubic. If that has a positive a and that has a negative a, that does something a little bit different. Cubics, you know, linears go one direction. Quadratics with squared, they go two directions, down, up, or up, down. Cubics go up, down, up, down, up, three things, or down, up, down. So the way that we look at this, it looks like this. Now you can see that kind of goes horizontal. It sort of goes up, down, up, down, up, like that. or down, up, down, like that. It doesn't necessarily need to dip. It can be flat in the center, but it's still a cubic because it goes two ways. It's like twisted. And so the next one starts down and then comes up like this. So you can see it begins by going up and down and up. Okay, so these are our basic ideas. And this could be, for example, a 7x cubed, or maybe this could be a -2 cubed. Something like that. All good? That's our basis for how to sketch these things. Any questions on that? You can always put the little thumbs up in the chat. You can put a thumbs down in the chat. You can say, hi, how you doing? I'm doing great, how are you? I'm great too. Or whatever, you know, whatever you need to do. But this is your cheat sheet. I like to make things simple whenever I can. Linear, this way. Cubic, up, or down, up, down. Quadratics go two ways. So let's go and make a rough sketch. The reason I wanted to go through all that is even before we use Desmos to help us, which we're going to, I want you to have some idea of what's what. So for example, this x, it's just an x. You should think to yourself, what kind of function is that? It's a linear function. The number in front of it is negative. So you have a negative 2 over 3. It's a negative a value, which means it looks like this. All right, so before we even do anything, we know that that's what our line should look like. Hopefully you're with me so far. Let's keep moving. I'm going to graph this on Desmos. Now, if you don't have Desmos or you don't know what I'm talking about, it is two things. It is a website that graphs stuff like this, which is it's awesome. It is the best tool for graphing things, even in university or college level, obviously. And it's an app on your phone that looks exactly the same on your phone, except I'd say it's even easier sometimes because you can put the numbers in quickly, all right? Now I'm gonna graph this. You can do the same thing. You're at home, why not? You know, you can even do it on a test to help you. I want to sketch this on Desmos so I can see what the important points are. So I'm gonna do that. I'm gonna put in -2 over 3, -2 divided by 3, x plus 5. And again, on your phone, it'll be the exact same thing. And I'm looking at this graph now. I can see that it looks exactly like I wanted it to. It's a line that goes down. So before I sketched it, I knew what it was going to look like. Now Desmos confirms it. How do I sketch this? Well, I'm going to take 2 points. In this case, I can see it crosses the y-axis and it crosses the x-axis. So I've got 2 points that are nice. I'm just going to write those down. 0.5 is a nice point. 7.50 is a nice point. And I'm just going to sketch it and I'll be done. Again, use this tool to your advantage. Why not? So let's see, 0 and 5. 1, 2, 3, 4, 5. So there's a point right there. And there's a point 1, 2, 3, 7.5 right there. And I'll connect them. Now, some of you are probably thinking, well, sir, I don't even have the notes printed. How am I going to do this? Right? I'm assuming some of you are thinking that. If you're not, then maybe you should be. There is an easy answer for that. You can use graph paper. If you don't have graph paper, just go buy it. All the stores are not closed, you know. Go in safe with your face mask and everything, but get a pack of graph paper. You should probably have it anyway. It's an important tool. Or, you know, find some other creative way to graph these things. But I'm expecting you to be able to graph it. I'm never going to ask you to do anything complicated. Just asking you to graph it somehow. So this is our sketch. Let me plot my points. This is 0, 5. This is 7.5 and 0. And so I've done a sketch. Before I talk a little more about this question, are there any concerns about it? It's a pretty simple function, but any questions? Nah. Okay, I'll take the nah. Some of you might wonder, well, I watched the video, sir, and Mr. Tom did a table of values. That is a very logical way to do these, and there's no reason why you can't do that. I just want to show you why I prefer Desmos. Now, both ways are fine. For a table of values, you have to know ahead of time which values to put in. And not every student is so good at that. So for example, let's say I just wanted to put in the numbers 0, 1, 2, and maybe I'll graph a couple more. If I put 0 in for x for this function, I get 5 back. Okay, 0 and 5, not bad. If I put 1 in, I get negative 2 divided by 3 times 1 plus 5. It looks like I get, I don't know if I did that right. Just 1 second. Negative 2 over 3 times 1 plus 5. Yeah, I get 4.3 repeating. Immediately ugly. And then I'll put a 2 in and see what I get. If I put 2 in, I get 3.67, okay, and so on. You kind of need to know ahead of time what your nice numbers are going to be. And you can do it, but you know, let me try to graph that. 0 and 5. 0 and 5 is there. 1 and 4.3 is somewhere over here, but you'd have to guess. And 2 and 3.67 is definitely there, but again, you'd have to guess it. So why not make your life easier? Use Desmos. This is the only way to get y values. No, it's not the only way. First of all, you can use Desmos to get your important points. One way that you can get the y values, Ibrahim, and I'll just show you another way, is you can set x to 0 and solve for y, or you can set y to 0 and solve for x. They will give you your numbers, okay? So for example, set x equal to 0. You get negative 2 over 3 times 0 plus 5. That means y is 5. So you'd have the point 0 and 5. If you set x equals 0, so set y equals 0. 0 is negative 2 over 3 x plus 5, and solve for 5. Solve for x. You end up getting, what do you get? You get negative 5 times 3 divided by 2. You get negative 7.5. And so negative 7.5 and 0. But that is a lot more work than just using Desmos. You know, why would you not use the graphing calculator to get the points for you? There's no reason why you can't do that. And so I'm not going to recommend that you do it by hand. I'm going to recommend you get it by Desmos. Okay. So hopefully that answers your question. I don't want to go too deep into this because it's only a small part of the course. All right. Any questions before I move on to the next example? I'll take the deafening silence as a no. Thanks, Yasser. Nice to know that there's still some humans out there. So first of all, 2 questions. What type of function is this? And what does it look like? So I hope that you're thinking about this and not just giving up. I know it's a tough time of day. This x tells me that it's linear. I know it's linear because it only has a power of 1. The number in front being positive means I have a positive number in front, a positive coefficient, a positive a. That means I have a graph that should look like this. Okay, I'm just going to, I could bring up my phone and graph this now, or you can do it on Desmos on the computer. So let's go ahead and do that. 1 over 4, 1 divided by 4, x minus 3. Looky here, I have a line. How exciting. Who said math can't be exciting? We can draw lines. We can draw lines. All right, let's find the important points right here and right here. 0, negative 3. 12 and 0. Those are 2 important points. I only need 2 points to draw a line, just connect them. So 0, negative 3. 0, negative 3, that would be right. Oops. That would be right over here. and 12 and 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What? Okay, I'm going to scale it. I'm going to go by twos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'll put my point right there. All right, and I just connect them. If you have graph paper, you can do the exact same thing. So let me connect those 2 points. You don't need to use colors. That's just my preference. And that's our answer. That looks a whole lot like the Desmos graph. In fact, it even has the exact same slope. So how nice is that? Label your points. This one was 12, 0. And this one was 0, -3. And you're done. You're done your sketch. You didn't need to do a table of values. You didn't need to do solve for 0 or solve for when x is 0, y is 0. You just use Desmos to help you. And I'm letting you do that, so why not? Okay. Any questions on that guy? Some of you are probably drove crazy because I keep asking. But when you have questions, you'll thank me. You'll thank me with giving you time. Nah, no questions, sir. All good. Okay, I'm just going to assume that you either know what I'm talking about and I'm doing a good job, or you don't care anyway. So just get it over with. And both of those I'll take as legitimate answers. But I hope that you're doing okay out there. You know, I want to bring a smile to your face. We're all in our homes, just looking at our 4 walls, sometimes our animals, staring out into the distance, watching the sun go down. It's nice to have some entertainment, even if it's not Netflix or a video game. Anyone do WhatsApp group? I don't know if you're talking to me or what. All right, so the next question is a cubic. I want you to do something for me. I want you to delete this guy. And we need to do 2x squared. So write in the chat, please. Is it a linear, quadratic, or cubic? And tell me if it opens up or does it open down? Quadratic, I agree with you. Q, 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 Q. All right, quadratic. Quadratic, yeah, I agree. Open up. So that means we're gonna have like this, opening up like this. That's a smiley face, right? So I agree. It's a positive A, which means it has a positive opening. You have your nice open up. That's kind of creepy. I'm gonna fix it. Oh wow, that's even worse. It's okay. I'm living on the edge here. That's our quadratic. It should look like that. Now our problem, folks, is when I graph this on Desmos, it doesn't give me, get off my plane. It doesn't give me enough points to work with. Oops, crap, oops. I feel like an old man trying to get around technology. Okay, here we go. It doesn't give us enough points, enough special points to make a nice graph with, or at least it doesn't look like it. But we can see here, let's see, it has the point 0, 0, so the origin is there. That's what it's called, is the origin, the center, or the vertex, I should say. Are there any other points that we can see off of this? Any ideas? What points I could use? I have a thought. I don't know if it will be any good. I see this point and this point are fairly obvious. Yeah, Hamza, Azada, thank you. It looks like 2 is going to be a good idea because -1 should give a 2 and 1 should give a 2. And in fact, those are really important points. I'm not going to draw it yet because I want to show you how to get it by hand, but oops, you are right and they will be there. Let's move this over. The trick for when you have quadratic is go left 1 and go right 1. So we want to go left 1. We want to go right 1 in our function. Or what I mean by that is you want the function when x is -1, and you want the function when x equals 1. What that will give us are two nice points to work with. It'll tell us how stretched our graph is. So if you put that in, that's 2 times -1 squared. -1 squared is 1, so that is a 2. No surprise there. This is 2 times 1 squared. That'll also give a 2. So that confirms what we knew had to be true. You can see it on the other side of the page. The graph already had those. I'm just showing you a way to do it by hand. And so our values, let me space this out just a little tiny bit so you can see the full picture. That means we have the point -1, 2. And this means we have the point -1, +1 and 2. And I don't want these getting lost in the mix, so I'm going to make them an ugly yellow. I apologize in advance, but I want them to stand out. So -1 and 2, I'll put that here. +1 and 2, I'll put them here. And then I connect them and draw the line. I might as well make it blue again. I've made the other ones blue. You don't need to be an artist here. I'm certainly not. I'm a musician, not an artist. But you need to be able to at least make a sketch. Not my best work, but it's okay. And I'm going to label these points. That's 1, 2. That's -1 and 2. And that's 0 and 0. Okay, 3 points, which can fully describe what I wanted it to be. So we can see here on our graph, oops. Man, I need to get used to these Zoom tools. They're not the most user-friendly. This point here is, 1 and 2. This point here is -1 and 2, so I'm okay. So I hope that makes some sort of sense. I want you to try D. I want you to give me 3 points that we can use to graph this function, okay? I'm going to delete this extra part, because technically we don't need to do that in this course. I just want you to graph this. Tell me what the shape should look like, what type of function, linear, quadratic, cubic, and then graph it. Or at least give me a sketch. Sad face. Okay. I agree with you. Quadratic. That's the sad face, all right, because we have a -a. We have a sad A. A sad day. It's a sad day when Mr. Scott makes you do work. Why can't I make this arrow? What is going on today? It's good enough. So it should look like that. Quadratic and it will be down, exactly Ibrahim, double Ibrahim. That's exactly right. And this is going to have, if I put 0 into this, when x equals 0, y gives 0. So I have the point 0, 0. So I definitely have a point here. What am I going to do? Go left and go right? Would be a nice idea. 0, -1, -1. -1, -1? So you're saying that there's a point here. And 1, 1. Okay. Does anyone agree or disagree with that? If you don't agree or disagree, that means that you haven't done it. And so you should have at least some idea of what we're doing here. I believe you put in a -1, which gives us -1 squared, which actually is a -1. F of 1 is -1 squared, also -1. Perfect. So I agree with your answers, Ibrahim. Thank you for being brave enough to write in the chat at 4:30 on a Monday. So I'm going to sketch this. Again, it should be curved because it is, it is a quadratic. Don't draw straight lines here. And even if you just have to draw a little sketch on paper without any graph paper at all, you should at least be able to write down a general idea of what this looks like. Okay, and this is our function. So there's one more thing I want to show you. The next question is a cubic. You can try that yourself. Let me show you what the a value in front actually does. Let me show you how it affects a graph. So the nice thing about Desmos is that you can make thousands of graphs in like a couple seconds. What I mean is, what if I put, sorry, I gotta move this, a x squared. Desmos is smart enough to know that a can be any number. So look, this is, for me being a total nerd about this stuff, like loving the way that this stuff works out, this is really cool to me. You don't need to be as excited, but I do want you to pay attention. In this case, a is 1. We have a standard quadratic, 1x squared, which is just x squared. It's kind of just a normal average function. If I make a bigger, what's going to happen? It has the effect of stretching it. Let me zoom out here. It's like it takes this function, and instead of just being a regular kind of healthy quadratic, it's like it's a rubber band. It pulls it. It makes it stretched out. So for every time you go over, we shoot up even more. Now, of course, we can make this even bigger. We can go from negative 100 to 100 if we want, and pull it even more. Pull it really tight, and it becomes like this really stretched out function. Or we can go the other way. If it becomes small, it goes to 0 and then gets pulled down negative. So that's why the a value has such an effect. Big a values above 0, stretch it big up that way. And then small a values, stretch it back out, compress it, go flat, and then it gets pulled down. So that's the effect that a values have on quadratics. Some of you may have never known that, so I hope that you've learned something today. Okey-doke. So that's enough information on quadratics today. The next question is a cubic. And I'm going to do it really quick just to have it there. If I put 0 in, first of all, this is a cubic. And this is positive a. So a cubic with positive a looks like this. Okay. Sorry if you can hear my son crying. He's earlier today, he was like really upset because he had to put on clothes. I think a lot of us can relate. So anyway, if he's screaming and you can hear him, sorry about that. If we put in a 0, put in x equals 0, we get 3 times 0, which is also 0. So it gives us back the point 0, 0. If we put in x equals negative 1, we get 3 times negative 1. Cube it, gives us negative, so negative 3. If we put x equals 1, that gives this. So I'll just quickly draw this. It looks like this: 0, 0, 1 and 3, and negative 1 and 3. It doesn't look quite right because it's really close in on itself, but it's good enough. I'm actually going to scale this just a little bit. I'm going to say our 1 is 1, 2, 3, 4. I'm going to say this is 1. 1, 2, 3, 4, 5. I'm going to say this is negative 1. And then I'll put my 3s. 1, 2, 3. 1, 2, 3. And it should look like this. Again, not an artist. Just doing my best. And it matches. And we can check that on Desmos if you want, but that's the big idea. So hopefully that makes some sort of sense. The big idea here is we need to know if it's a linear, quadratic, or cubic. Once we know that, we can just check a couple points, put them on our graph, and we're done. I guess I should label these. Okay, before I move on to the next topic, which is domain and range, is there anything I can clarify about any of these types? Is everyone still with me? Still alive out there? You're good. I'm glad to hear that, Kevin. Carry on, carry on. Carry on my wayward son. There'll be peace when you are done. You know that song? You know that song? So, you know, that? It's not, I guess it's not music class, so I should probably put this down. We'll have a jam session some other day. Where did I put my pen? Okay. So the next topic. Oh, verifying. Man, I'm going slow today. I forgot we even had this topic. So verifying if a function is actually the function that we want it to be. Tom already covered this. So I'll quickly, we should do a jam session one day. You know, on Zoom, it's actually quite difficult to do that because you think you're talking at the same time, but there's like a 2 or 3 second delay from when I say something to when you hear it. So when you jam, when you play music online, like I'll be playing a note or a chord and you'll hear it 3 seconds later. So you're trying to match that and it just sounds really terrible. But you never know. I'm up to try it for sure. Let me try and get through this topic as quickly as I can. So sometimes we need to verify if the graph of a function matches its equation. And what we need to do that is we want to find ordered pairs that fall exactly on intersections of grid lines, and we want 3 of them. We want 3 ordered pairs, generally. Three points. So let me get to the point, because I've been on a tangent today. I don't want to waste anyone's time. Let's just say we were given this function, which we have been. That's a function. I'm telling you that as a fact. We want to know if that function or that equation matches its graph. So first things first, we look at the graph and try to find some nice points. By nice, I mean it comes exactly on an intersection. So let's just look at this graph here. Right here, that would be a nice point. By nice, I mean, look, you can see it is exactly on an intersection of grid lines. So we know exactly what it is. It's 2 and 5. So we can say that's the point 2, 5. If we need it later, we can use it. In fact, I'll start keeping track of them here. A point on the graph is -2 and 5. I meant to say -2, not +2. All right, so someone give me some other nice points. There's 4 more nice points on this graph. Someone give me them. Just type them in so I know you're still breathing, still thinking. I know it's hard to think at this time. You can imagine it's hard to teach at this time too. So we're all in this together. Anybody, give me a point. Give me a nice point. You can all see this. 2, 3. Let me check it. 2, 3. I think you mean 3 because it's down. But thanks for typing. 2 and -3. So 2 of you said that. -6 and 5. -6 and 5. +6 and 5. Okay. Yep, perfect. +6 and 5. 2 more. No one said them yet. I'm looking at you, 4, -1. I'm looking at you, 0 and -1. So I'm just going to write them down left to right. 0 and -1. Then a 2 and -3. A 4 and a -1. Finally, a 6 and a 5. All right, so those are 5 nice points. I told you you only need 3. I'm just taking 5 so that you can see it doesn't matter which ones you choose, okay? It makes no difference at all. We need to take 3 of those x values, put them into our function, and see if they give back the right y. So which one do we want to start with? Well, first of all, I'm going to make some space so that I can put it into my function. I'm going to start with the easiest possible one. And the reason for what I mean by easy is I'm going to start. Yeah, Mohammed, you have a question? I see the raised hand. No? You're just playing around with tools? I'll go with that. I'm going to choose x equals 0 because usually zeros are nice to work with. So the function when x is 0 is 1 over 2, 0 minus 2. It's okay. It's good to know that it works. I mean, anyone who raises a hand, I see it right away. So that's actually nice. Minus 3. So once again, I'm putting in 0. I'm replacing all of my x's with 0. That's what I started doing yesterday. And my final answer here, let's see what it gives. I don't have this one worked out. Negative 2 squared is a 4. Half of that is 2 minus 1. So this is 1. Is it? Let me try this again. 0 minus 2, square it, divided by 2, minus 3. It's negative 1. Sorry. So if you've been following, this actually is good. Because look, 0 is what we put in. Negative 1 is what we got back. So what I can say is that 0, negative 1, this point down here, I just filled it in with green just so you can see it. This point is okay. It's perfectly fine. It definitely matches the equation. And so maybe I'm actually on the right track here. I'm just going to choose any old function, any old other numbers, okay? So I'm just going to go ahead and try the next one. When I put in 2 to this, I get a half. 2 minus 2 squared equals 3. That actually will cancel this whole term. You can try that yourself. But I end up with negative 3. So once again, I get 2 and 3. This value is perfectly fine. 2 and negative 3 match. I'm on the right track. If I can confirm even one more point, this will be our function. So let's do that. Let's try the next one. It doesn't matter, we can try any of the 5. 4, 1/2. 4 minus 2. Square it, minus 3. 4 minus 2 is 2. Square that, we get 4. It's the same thing as we did in the other case. It's negative 1. And that works. 4 and negative 1 is here. And 4 and negative 1 is what I got back. So indeed, my equation matches my function. So now, hopefully, if you've seen the video that Tom made, you had his explanation. Now you have my explanation, and I hope it's crystal clear. I'm going to have you do one. Is there anything that I can explain before I do that? Oops. I'll take that as a no. If. Sorry, is that a question? Okay, so you have to check 3 points. And if one of them is okay, that's a good thing. But that's not enough. You have to make sure that 3 are correct. On the other side, if even one single value is not the same, it's not a function. Okay, it's not the same function. No, it's not, because sometimes, for example, let me just show you this. I'll just draw a little sketch. This function has the point, let's just say it has the point 2, 0, okay? And I have some other function that comes in. both of these functions have the point 2, 0. But that doesn't mean they're both the same function. We might have accidentally put in that number and gotten back 0. It doesn't mean the rest of the points are okay. If we check -2, we would get this one for that function and a totally different one for the other function. So we have to check 3. So your question's coming in, how can we know if it's correct or not? Let me go back to here. Let me see if it says it here. Okay. Let me make it crystal clear. It is the correct graph if 3 points match. All right, if they're the same, 3 points. You had to have 3 confirmed points and you know you're okay. I can say it is not the graph if 1 point does not match. Sorry, my writing isn't perfect. It is not the graph if even 1 is wrong. If a single point is not the same, cancel the whole question. It's not the correct function. Is that okay? All right, so I'll give you a chance to work through this. We still have another topic to do after this, but it's a pretty short one. Give this question a try. All right, is the graph of the function, so is this equation this graph? Yes or no? I'll give you the points that you can try. I want you to see and tell me if it's the function or not. So you can try any of these points, all right? I'll just mute myself for a minute so you can have time to think. Take 2 minutes and tell me if this is the function of that equation or not, if it's a graph of that equation or not. Anybody have any thoughts? I'll give you another 30 seconds. Okay, I'm seeing it's not a function. Got 10.1 for the first one. Okay, so you're saying for this one, I'm not going to do the full workings because you can do that yourself. It seems like my y value, 10.1. Well, I'm going to put a little x by that because that's not 10. So it seems close, but not exact. I got 1. For 1, I got 5, not 4. Okay, so you're saying for this one, you put 1 in, you're getting back 5, not 4, yeah? So I'm going to say that's not correct. Well, we only needed to check 1. Did anyone else check any other numbers? Ibrahim, oh, you, okay, so I got yours. Did anyone else check -3, -1, or 3? I'm just asking so I can get the quick answer. It's okay if you didn't. Honestly, we're done. We could have been done right away. So here, so no. This is not a graph of f of x because the point does not match. You know, this point here, -5 and 10, doesn't match. The point 1 and 4 doesn't match. That's all you need to know. You could have done just 1 point. All right, not a graph. Halas, we're finished. We could have checked just 1, but we checked 2 just to be safe. -1 is 2.3. Okay, I might as well write that in. -1 gives 2.3, not 2. They are not the same. This is not a case where we can just get to the closest number. We have to be exact. And so we can see for sure it's not the same. Okay, so I think we've pretty much exhausted that topic. Thanks everyone for participating. It keeps me awake. Lets me know there's someone on the other end. Okay, so no, it's not a graph. C here, you know, it's the same basic idea. You can just try it for homework, okay? Of course, everything now is homework, but what I mean is for the assignment or the tests, this can be something you can try before now and then, before then. Okay, and I highlighted some stuff here. You can't conclude the graph is correct by just checking 1 point. That goes back to Yaya's question. You need to check at least 3, unless it's not matching, in which case you only need to check 1. And that's about it for this. That's how you check functions. So can you tell me if any of you have seen domain and range before? Because it'll totally change the way that I approach this, depending on if we're comfortable with it or not. Have you seen domain and range, yes or no? Yes, okay, Yasser, you've seen it. Yes, Kevin has. Anybody else? Some students are totally unaware of really how this works. They don't have a good concept. So yeah, Ibrahim, you haven't really seen it before. So that's what I'm looking for. So right away, that's all I need to know. I'm not going to play as if you're stupid or something. I'm just going to explain it in a slightly different way so that everyone gets the full picture. So first things first, what does domain mean? The domain of a function tells us about our x values. What does it tell us about our x values? It tells us all possible x values. Or in other words, all possible inputs that we can put into a function. Or all possible input values, all right? So let me give the full word. All possible input values, which values we're allowed to use. The range, you can probably guess what I'm gonna say here. The range has to do with the y values, and it is all possible output values. It's all the possible numbers we can get by putting in input values. Now, many students have trouble remembering what the domain is, you know, connecting domain to x and connecting range to y. And I've got a quick way of remembering this, okay? So, domain is related to x. How do you remember this? Well, think about the alphabet. D, the letter D, comes before the letter R. I think you all know that, even if English isn't your first language. A, B, C, D, oh, we've got D. It comes before R. Well, by coincidence, just by chance, X also comes before Y. Of course it does. X, Y, Z is the order. X comes before Y. Why am I giving you an alphabet lesson? Because that reminds you that domain is related to X's and range is related to Y's. That's the big idea. Now, many of you all of you should have watched Tom's videos on this. But it's such an important topic. It might be the most important topic for functions to understand them. I wanted to start it again from scratch. So we're going to do some examples, but let me give you a few tips first, just so we can have a reference, and then we'll start. First of all, if you ever access these QR codes on your phone, they'll bring you to videos or Desmos stuff, things that I've linked to that I think would be useful. So you can, put up a QR reader on your phone and just go, it'll take you to somewhere that I thought was important. I made those myself. They're not just weird formatting problems on the page, okay? The other thing I'll say about domain and range, this is the process that you should follow. The 3 things I think you should do when you're given a domain and range question. First thing, I think you should graph it. Use Desmos, get an idea of what the graph looks like, go from there. Second step, determine problems with the x values. The problems are dividing by 0 or getting the square root of a negative number. We do not want square roots of negatives. In this unit, we're dealing with real numbers, not complex. So even though unit 1 had complex, it's not complex now. Just real. Third, now you write the domain and the range. And how you write the domain looks like this. You put D with 2 dots. You say it's the set of x values such that, and then you have some rules, and then you'll say it's x is part of the real number system. That might look crazy to you, but it looks the same every time. You'll get used to it. So range is the set of all y values such that, that's a vertical line. You give it some sort of rule, and then it's all in the real number system. So let me show you an example before we go any further. Let's look at this question. Determine the domain and range for this function. Now, you probably don't know what this function looks like. Why would you? So instead of doing a table of values and stuff, I'm going to go right over to Desmos, and I'm going to graph it. And you should do the same thing. You can put your phone right in front of you right now and put this exact same function in. There's nothing stopping you. It's not difficult. So I'm going to do the square root of 3 minus x. This is what this function looks like. And I'm going to need your full attention now because this is not obvious to most people. Remember what, let me see if I'm in projector mode. Yeah. Remember what domain means. Domain. All possible x's, all possible x values. So allow me to demonstrate. Can I put a -10 into this function? Of course I can. It exists at that point. It exists. Can I put a -5 into this function? Of course I'm allowed to do that. It'll give me back a number. There's nothing wrong with that. Can I put a 0 into this function? Of course I can. Can I put a 2 into this function? Yes, I can. Can I put a 3 into this function? Yes, I can. Can I put a 4 into this function? No, I can't. This function does not exist anywhere after 3. The function, if I zoom out here, I'll just clear this. This function, sometimes I hate this system. If I zoom out, this function actually goes on forever. You're allowed to go forever in that direction. All those x values exist. The problem is the x values don't exist after 3. So the way I write this is quite simple. Look, domain is the set of all x values such that x is anything less than or equal to 3. Why? I'll repeat it one more time. Why is that true? It's because at 3, all of this here, x less than or equal to 3, is okay. It exists. There's a function there. After 3, there's nothing. That's all I'm getting at. So there's no function when x is greater than 3. Okay? So hopefully that makes some sort of sense. I'm going to show you another way to think about this, and then I'll give you a shortcut, because I know a lot of you want to have a shortcut for how to remember this stuff. So x is part of the real numbers. So again, I'll read this out. The domain is the set of all x values such that x has got to be less than or equal to 3, and x is a real number. X is part of the real number system. Okay, let me clear these annotations here, and I want to ask you a question. I've been asking a lot of questions, but that's the whole point of math. Oops. Range. Looking at this function, what are all the possible outputs? Or in other words, what are all the possible y values of this function? What is the set of numbers that are allowed to exist given this function? Anyone have any ideas? Anybody? Going once? Going twice? Maybe I've used up your last brain cell, but I'm trying to make it as clear as I can. You can always watch these videos later. Positive y's. Kevin, my man. All of these y's are okay. Look, all of these are fine. This whole region, they all, of course, those y values all exist. Y can be positive, greater than 0. Can y be 0? Yes, it can. So greater than or equal to 0. The problem is we don't have anything below 0. We don't have any y's down here. There's no y values. There's no function down there. And so our final answer here, y must be greater than or equal to 0. The rest is the same, okay? So the important part of this, these are really the main parts. The rest is like the same all the time. X has to be less than 3 or equal to 3. The y's have to be bigger than 0 or equal to 0. They don't exist below those, okay? So that might break your brain a little bit. It's okay if it does. I hope that slowly it'll start to make more sense. That's my hope. Let me give you a shortcut for figuring this out. Actually, I'll do one thing and then show you a shortcut. First of all, maybe you wanted to figure this out without using Desmos. Okay. This square root, we're not allowed to have the square root of a negative, not in this chapter. So let me show you something. We want this to be positive, so we'll say 3 minus x has to be greater than or equal to 0. If it's not, we're going to be getting the square root of a negative number. So what we do, we solve this. 3 minus x equals 0. Okay, move that x to the other side. That'll give us 3 must be greater than or equal to x. That's kind of useless. Let's look at it from the other side. That means x must be less than or equal to 3. If x must be less than or equal to 3, well, that's what Desmos told us. So we've confirmed our answer. Some of you might like that. Some of you, it might be a little too late in the day to appreciate that. But take time to think about it, at least at some point. Long story short, Scott, give me the short way to do this. Okay, I will. Unfortunately, there's no real short way for domain, but there is shortcuts for range. And these are the shortcuts. If you have something, square root form, someone just left. If you have something in square root form, which means you have something under a root, usually, which means most times, the range will have y greater than or equal to 0, which is exactly what we just got. Finally, if you have something in what we'll call 1 over x form, usually, which means most times, has a range of y cannot be 0. Y is not equal to 0. So when we look back at this, range of y greater than or equal to 0 is over here because of the square root form. Okay, so these things all connect. Let's do another one from scratch, okay? I'll do a quick one. Domain for this function is the set of all x values. Now, I think I missed a point. Well, I said something earlier. We're not allowed to divide by 0, and we're not allowed to have square roots of negatives. What is the problem with this domain here? Are there any points we're not allowed to use? Or we're going to divide by 0? Well, for those of you who are still paying attention, negative 7x is not allowed to be 0. If it's 0, we're dividing by 0, and we know that that's a big problem. That's a math problem. It's a big math problem. So what does this give us? Well, we divide both sides by 7, and it actually is telling us that x is not allowed to be 0 for this function. So that's our one condition. We can say x is not allowed to be 0, and other than that, x is part of the real numbers. Halas, okay? This is done. And the range I'm going to give you for free. This function is in 1 over x form. I think I made that purple earlier, so I'll make it purple now. Purple functions. Functions in that form, 1 over x form, have a range where y cannot be 0. So we say y cannot equal to 0. Oops. All right, and now we're done. That is our domain and range. That is not easy. That's complicated. It's tricky. So I know it's late in the day. If you've decided that you've kind of took it all in by now, you can't handle anything else, I get it. What I will ask you to do is please, please, please review this stuff, because it's going to keep coming back, and I'd rather that you have a good handle on it than just forget about it and it comes back to haunt you later. Okay? So that's the end of that question. The question here for x, I'll leave for you as an exercise that you can do before the assessment is done. The next topic is piecewise functions. I won't do that today, but if you want, you can even just watch my other class at some point to get that. I may cover it tomorrow, I may not. So I think I've pretty much exhausted myself. Are there any questions you have for me before I stop the recording? In fact, I'll stop the recording. You can still ask me questions. Bye-bye, everybody. See you next time.